Hello, ladies and gentlemen. Today we're going to be talking about how to add and subtract rational expressions with simple denominators. So in this unit, we've already talked about how to simplify rational expressions, how to multiply and divide rational expressions, and we've even talked a little bit about adding and subtracting, but so far they've had the same denominator, and today they're not going to have the same denominator. So our goal is to add and subtract things or fractions when they don't have the same denominator. We're going to have to figure out what to do in that situation. Like always, you're going to need your notes, pencil, calculator if you so wish, etc. So our required knowledge before we even start is to know that in order to add or subtract fractions, remember rational expressions are basically fractions, you need common denominators. We've already done adding and subtracting when the problem has given us common denominators, but now our goal is to have to create common denominators. So if we look at these two basic problems or review problems because they're just simply adding two fractions, so this should be review. In order to add these two fractions, my goal is to get 7 and 21 to have the same denominator. So think about multiples, factors, multiplying, all that stuff. Is there anything that we could do to 7 to get it to 21? Well, yeah, we can multiply it by 3, but whatever we do to the bottom half of the fraction, we have to do to the top half of the fraction because otherwise I'm not going to be getting back the same fraction and we don't want to change the expression completely. So let's multiply. 3 times 2 is 6. 3 times 7 is 21. So that 2 over 7 becomes a 6 over 21. And now let's add it to 4 over 21. So that's going to change to 6 plus 4 all over 21. And we know 6 plus 4 is 10 over 21. Before we circle it and claim that we're done, we need to ask ourselves on every single step for all these problems, is this the simplest form? Yes. 10 over 21 cannot get any simpler. The factors of 10 are 2 and 5, 1 and 10, and the only one that they have in common with 21 is 1. So that means that we are done simplifying, and that's as good as that answer is going to get. Okay, now let's try 4 over 3 plus 2 over 5. So now we can't multiply anything to get from a 3 to a 5 or from a 5 to a 3, but we can multiply both of them. We could multiply this by 5 to get to 15, and we could multiply this by 3 to get to 15. So 5 times 4 is 20, 5 times 3 is 15, plus 2 times 3 is 6, over 5 times 3 is 15. Now we have 20 plus 6 all over the same denominator, 15, and 20 plus 6 is 26, all over 15. Can we simplify? Quick answer is no, circle it. So now we're going to use the knowledge that we just did on the basic problems with algebraic expressions. So we have 2 over 3 plus x over 12. So we need a common denominator. Well, I know that 3 goes into 12 4 times. So let's multiply that left-hand equation by 4. 4 times 2 is 8. 4 times 3 is 12. So we get 8 over 12 plus x over 12. 8 plus x all over 12. There's nothing that we can do to simplify here because remember, in order to go slash happy, we have to have factors in the top. And right now we have 8 plus x. So there's no way to break that down. We can't factor it anymore. So you can write your answer as 8 plus x over 12 or x plus 8 over 12. That's technically standard form. So you'll probably see me write the variables on the front or on the left side. So I'll accept either, but just know that I'm going to write my final answers like this, x plus 8 over 12. All right, moving on to number 2, 4x over 7 plus 1 over 5. 7 and 5, we can't multiply anything to get from 7 to 5 or 5 to 7, so we're going to have to multiply both of them. Well, I know 5 times 7 is 35, so let's multiply this by 5 and this by 7, so that we have a common denominator of 35 for both of these, yes. So now we just need to do the numerators. 5 times 4x is 20x over 35. And then we have plus 1 times 7 is 7. all over 35. Now we have 20x plus 7 all over 35 in one fraction, and I can't simplify that anymore. I can't factor 20x plus 7 because 20 and 7 have no common factors other than 1. So that means that this is my final answer. Moving on to example number 3, we know that 2 times 5 gets us to 10. So we're going to multiply the left-hand equation, top and bottom, by 5. When we multiply by 5, we're multiplying the entire numerator times the entire denominator. So when we multiply by 5 times x plus 1, we're going to have to distribute that 5 to the x and to the 1. So that's going to become 5x plus 5 all over 5 times 2 is 10. Plus my other fraction is 9 over 10. Now we can merge that into one big fraction, 5x plus 5 plus 9 all over 10. Well, 5 and 9 are like terms, so that means that I can add them. So now I have 5x plus 5 plus 9 is 14 all over 10. Well, 5 and 4 in the numerator don't have any factors in common, so I know that I can't break that down any farther. And since we have an addition sign in the numerator, I don't have any factors, so I can't slash anything. I can't reduce 5 over 10 as 1/2, and I can't reduce 14 over 10 as 7/5, excuse me. So then that means 5x plus 14 all over 10 is my final answer. Example number 4. 2 times something to get to 3. That's going to be rough. Or 3 times something to get to 2. That's going to be rough. So we're going to have to multiply both fractions by the opposite denominator so that we can get a common denominator of 6. So we have 3 times 2 to get to 6 and 3 times 2 to get to 6 on the right. So 3 times x is simply 3x all over 3 times 2 is 6 minus, now remember, when we're multiplying this numerator by 2, it's the whole thing, so we're going to distribute. 2 times x is 2x plus 2 times 2 is 4 all over 3 times 2 is 6. So now we're subtracting these two fractions. And when I'm subtracting, when I write it in the big fraction all in one, we're saying 3x minus this entire thing. When we say minus, we're minusing this whole numerator. So that means I'm going to have to put up parentheses, distribute the negative. So I have 3x minus 2x minus 4 all over 6. 3x minus 2x, I can combine those like terms. So a 3 minus a 2 would leave me with a 1x minus 4 all over 6. We can't simplify that any further, so that is my final answer. And we have two last examples, 5 and 6. So number 5, we are looking at 6 as a denominator and 2x as a denominator. Well, I can multiply this guy by 3 to get to 6, but what about this x now? In order for us to have a common denominator, we're going to need a common denominator of 6x. So on the left-hand side of the equation, my x over 6, I'm going to have to multiply the top and bottom by x. And then on my right-hand equation, fraction, I have 7 over 2x. I'm going to have to multiply that guy by 3 so that we get a common denominator of 6x. So far, examples 1 through 4, we've only had to find common denominators with numbers. Now we're going to have to find common denominators with numbers and variables. So don't just multiply by the 3 and forget about the x on the other fraction. We need a common denominator of 6x. So that means that if I work from left to right, x times x is x squared over 6x, plus 7 times 3 is 21 all over 6x. Now we have x squared plus 21 all over 6x. I can't factor x squared plus 21, and that doesn't get any simpler, so that means that I can't go slash happy. So my final answer is x squared plus 21 all over 6x. I'm going to change my pen color to purple. All right, example number 6. We're going to have to multiply probably both of them again because we can't get from a 5 to a 3 or a 3 to a 5. So let's multiply this by 3. But remember, our goal is to have a common denominator with x in it. So that means we're going to have to multiply by 3x. And then on the right, we're going to have to multiply by 5 to get to that 15x as a common denominator. So 3x times 9x, 3 times 9 is 27. X times x is x squared. 3x times 5 will be 15x, all minus 1 times 5 is 5, all over 3x times 5 is 15x. Now I have common denominators, 15x in both, and I'm simply subtracting. So I have 27x squared minus 5 all over 15x. So I can't factor 27x squared minus 5, unfortunately. So that means that I can't simplify or go slash happy. So this would be my final answer, 27x squared minus 5 all over 15x. All right, before next class or before the next time I see you, I want you to try these 2 example problems on your own. They will be graded, so please, 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 please do them in your notebook so that when you come to class, I can check them and we'll go through what the answers are after I grade that you have done them. So try your best on these and I will see you soon. Thanks for taking the notes. Peace out.